All right, let's continue with solving some of these rate of change problems. Okay, what is the constant rate of change? Okay, so whenever you see the word constant rate of change, well, this just basically means what's the same. In other words, we can find a unit rate, and the word, of course, unit rate means uni one, so we can find the value of one, and that's pretty much the rate of change. And so, in rate of change, usually we can divide to find the rate of change. For example, look at this ratio here: 234 miles in 4 hours. Well, I know it's miles in hours because it tells you, and usually when we talk about the relationship between miles and hour, we say miles per hour. And so now we have miles over hour, 232 miles in 4 hours. Well, if I want the rate of change or the unit rate, all I got to do is divide. So I'm going to divide, and I want the value of 1. So I'm going to divide by 4. And so when I divide by 4, I'm going to get 234 divided by 4. And I can see 4 goes into 23, what is that? 5 times? 5 times 4 is 20. Bring the 3 down. I'm sorry, bring the 2 down, because 3 minus 0 is 3. 4 into 32 is 8. And I can see right there that it's going to be 58 miles in 1 hour. That is my rate of change. Or some people would say my unit rate. And so my unit rate, which is this, is right here. That's a unit rate because we have a 1. And so that's my answer, which is C. Okay? You're going to do the same thing for number 2. The same process, same thing, and you get your answer. You have 2 ratios given to you. You have this one, 8 ears of corn, acorns for $2.40, or 5 ears of corn for $1.50. Well, find out how much 1 corn costs. Same thing. The cost over how many corns you have. Cost over corns. Okay? So just make a fraction, find the unit rate, and divide, and you'll find your constant rate of change. Okay? We're going to go to number 3. The relationship between the cost of corsage and the number of flowers in the corsage is shown below. Which statement is true about the information in the table? Well, when you have a table, we can look for a pattern in the tables. In other words, the number of flowers, what is the change? How much are they changing by? Well, they're going from 2, 3, 4, 5. That means they're changing by 1. Because 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. And so now what are the cost of the corsage changing by? Well, from 7 to 1050, there's a change of 350. Now 7 plus 350 is 1050. That means that if this is to continue, 1050 plus 350 is 14, and it is. And that means if it continues more, then $14 plus 350 is $17.50, and it is. So my rate of change, or the way we put it in symbol, rate of change, the change in the y over the change in the x. So the change, in other words, the change in the y's, and then here, number of flowers, well, there's no x, but there's an f. Cost of corsage is c. There's no y, but you got to think here, okay, what depends on who? Remember, your x is your dependent, your independent, and your y is your dependent. So, does the number of flowers depend on the cost, or does the cost depend on the number of flowers? So in this case, the cost, well, it depends on how many flowers are ordered. So then this guy is my independent variable, and this guy is my dependent variable. He depends on him. And so now it's changing y over x. So my change in the y's was 350, so that's going to go on top, over the change in the x's, or the number of flowers, which is 1. And so I can say 3.5 over 1. So that means my answer is A. Constant rate of change is 3.5. Okay. Number 4 there says there, Carrie created a pattern with rectangles. So pattern, her first step, 1 rectangle. Second step, 3 rectangles. Third step, 5 rectangles. What is the constant rate of change? In other words, what is the pattern? Okay, what is the unit rate? So let's see here. The first step, we had 1 rectangle. The second step, we had 3 rectangles. The third step, we had 5 rectangles. And so now look at the, what's the pattern? Well, from 1 step, we have 1 rectangle. 2 step, we have 3. 3 step, the third step, sorry, we have 5 rectangles. What's the pattern? Okay, think about it a little bit. How many rectangles? From 1 to 3 to 5. Look at your choices. Think about what the answer is. Number 5. What is the constant rate of change? You're going to do this like you did this one. Okay. Find the pattern in the x's. Find the pattern in the y's. It's already given to you. Find the pattern. And it's the change in the y over the change in the x. So find the pattern, and then you can see it in fraction form. Number 6 there. Okay. Number 6. Which table shows a constant rate of $3.25? So which? So that means that the cost of 1 sandwich is $3.25. That gives it to you. Okay. The cost, and then look at G. The cost of 1 sandwich, $3.25. Okay. 1 sandwich, $3.25. 1 sandwich, $3.25. So then they all give you the same amount. So that means that I cannot just answer the question using the cost of 1 sandwich. Okay. Oh, and so I got to find the cost of now 3 sandwiches. And so that means $3.25 times 3, because it's each sandwich costs $3.25, because the constant is $3.25. So 5 times 2 is 15, carry the 1, that's 7, 3 times 3 is 9. So that means that 3 sandwiches would cost $9.75. Well, they put $10.50, not the right answer. So that's not going to give me the answer. $9.50, not $9.75, again. So I don't have a choice. $9.75 is here, good, but then it's also here. So now that didn't help me find the cost of, well, it helped me to eliminate 2, but now I gotta eliminate one of these, and the cost of 1 is not gonna help. The cost of 3, no. So we gotta find the cost of 5. So $3.25 times 5. So 5 times 5 is 25. 5 times 2 plus 2 is 12. Carry the 1. 5 times 3 plus 1 is 16. 16.25. And so that means that the cost of 5 sandwiches is 16.25. Well, that's 15, that's 16. That means this is the answer right there. Okay. And so number 7, you're going to follow the same process. Okay, the same thing. Okay, so now your rate of change is 5. Okay. Your rate of change is 5. So you can do the same thing. Okay. Except now your x values are here and your y values are here. So then that means that 5 is your rate of change. Well, how did you figure this one out? Well, 325 times these, times your h's or your x's, would give you the y's or the c's. Well, the same thing here. 5 times 3, does that give you this answer? Okay, 5 times 2, does that give you that answer? Okay, or 5 times 1 is that answer? Okay, when you look at this one, does 5 times 1 give you 6? Does 5 times 3 give you this? Okay, so now you look at this one. 2 times 5, does it give you 10? Is 4 times 5 20? Is 6 times 5 30? Is 8 times 5 40? Okay, so whichever one you think is correct. 3 times 5, is that? 2 times 5, is that answer? Negative 2 times 5. Okay, so the constant the same, the rate of change is 5. So that's why I put a 5 there. Is it true that you get an answer? So one of those is the right answer. Okay. Number 9 is just, it's a basic problem. You can figure that out. And number 10 is also something you should be able to do on your own. All right, good luck. Bye-bye. Oh, quick shout out to Aidit.